Hello students, welcome to my channel Mary Madam Tech Classes. Today we are going to continue from the same chapter, Statistics. The next topic is correlation. What is a correlation? Correlation is nothing but it is a statistical measure. The correlation quantifies the strength of the linear relationship between a pair of variables. If you move into our topic, data scientist's VP of growth, it has a theory that the amount of time people spend on the website is related to the number of friends they have on the website. And to verify this, let us say after digging through traffic logs, you may come up with a list called daily minutes. That shows how many minutes per day each user spends on data scientist. And if you have ordered it so that its elements corresponds to the elements of our previous number of friends list. What does it mean? In a website, each friend or how much time you are going to spend with your friend in a day, or number of friends daily per minute. How much time you are going to be spent in a website and with your friends. Now we would like to investigate the relationship between these two matrices. Okay, then let us first look at the covariance, the paid analog of the variance. Whereas variance measure how a single variable deviates from its mean, and covariance measures how two variables vary in tandem from their means. Here we are going to see about variance and covariance. Variance measures how a single variable deviates from its mean, but covariance measures how two variables vary in tandem from their mean. Tandem nothing but front and back. Which is the first one and which is the next one? How they are going to be related to one to another. Let us see here. Little bit of code is given. We are going to use dot operation. Dot function, we are going to use here dot function. If you observe, we are going to use the dot function. So for that one, we are going to use dot. We should import a dot from scratch linear algebra. We are going to define the covariance. Covariance is also a built-in function. Covariance with x's and y's. Here we are going to take a x's list and y's list with the floating values, and it returns with a float value. Here we are going to take the x's and y's. The elements must be same. For that purpose, we are taking the asset function. Asset of len of x's must be equals to len of y's. So x's list and y's list number of elements should be equal. Now we will get what we are going to get written dot of d mean of x's, d mean of y's by len of x's minus 1. If you see here, len s means number of elements in the x's and number of elements in the y's may be same. It should be same. So that's why we are taking either len of x's or len of y's. But here we are taking len of x's minus 1. This is the formula to calculate the covariance. What we are going to get, if we observe here, the covariance is calculated with two measures, number of friends and daily minutes. And the output will come between 22.42 and 22.43. So here how much values will we are what is the value is going to be get? It comes between 22.42 and 22.43. And if it is with covariance of number of friends and daily hours, if we calculate this one, it will come between 22.42 by 60 and 22.43 by 60. That is going to be up here. If you see here the covariance of the formula for the statistics, if you observe, just now we have taken covariance of x's and covariance of y's. It is our list. But here we are taking, if you see the formula of statistics in statistics as covariance of x comma y, two variables x and y. The formula is sigma of xi minus x bar. X bar is nothing but mean of x. Yi comma y bar, mean of y. Xi is the data value of x and data value of y, yi. Now what is n? N represents the number of data values. If you take x is equals to 3 elements, y is must also be 3. So that's why we have taken in the previous thing as, what does it mean? Here if you observe here, that's why we have taken that len of xs minus 1, if you observe the thing. So next, if we see what about the correlation formula in statistics, R is the correlation coefficient. What does it mean? Sigma of xi minus x bar, yi minus y bar. As just now we discussed about, y bar is nothing but mean of yi, and x bar is for mean of x variable. And here if we observe here by covariance and correlation, if you see the differences of this one here, what is the difference? If you observe, both are same, but by values are somewhat different. If you observe, what is the correlation and covariance? Here n minus 1 is the number of elements minus r len of xs minus 1. If you see here correlation of root of sigma xi minus x bar whole square, sigma yi minus y bar whole square. This is the relation between correlation and covariance formulas. Let us move into our topic. It's more common to look at the correlation which divides out the standard deviation of the both variables. If you see here, our both variables are x's and y's. If you take x's as number of friends and number of daily minutes, if you observe here, let us see about the small code here. We are going to define the correlation with x's and y's list. Here if you see the thing, same thing, x and y are varying intended between them, means we are going to calculate the standard deviation of x is equals to, we are using the same thing, built-in function standard deviation of x's and standard deviation of y's is standard deviation of y. If you observe here, if standard deviation of x is greater than 0 and standard deviation of y is greater than 0, it will return what it will return? Covariance of x's comma ys by standard deviation of x by standard deviation of y. Otherwise it will give 0. It returns 0 if no variation, and correlation is also 0. The output will come here in the form of, if you observe, number of friends with the daily minutes, the correlation values is 0.25 between 0.25 and 25. If the variables are number of friends, daily hours, the output also will come between 0.25, 0.24 and 25 values. This is about the correlation, how it comes. The correlation is unitless and always lies between -1 and 1. -1 is the correlation is unitless and always lies between -1 and 1. minus 1 perfect anti-correlation, 1 perfect correlation. A number like 0.25 represent a relatively weak positive correlation. 0.25 is a weak positive correlation. However, one thing we neglected to do was to examine our data. If you check our figure 5.2, the correlation with an outlier. If you take 100 friends, if you observe here 100 friends, outlier, correlation with an outlier. Where is the outlier? If you observe here, outlier is at index at the point 100. If you observe, just now we discussed about number of friends, number minutes per day. X-axis number of friends, Y-axis is minutes per day. If you observe here, this is about the figure correlation with an outlier. The person with how many friends? The person with 100 friends who spend only 1 minute per day on the site. It is a huge outlier, and correlation can be very sensitive to the outliers. What happens if we ignore outlier? What will happen? If you say here, outlier is equals to number of friends dot index of 100. The index of the outlier is 100. Number of good friends. If you see here, number of good friends is equals to x for I comma x in enumerated number of friends if I is outlier. Same thing. Daily number of friends, x-axis, y-axis, number of minutes. Not only minutes, daily hours, daily minutes and daily hours. What are the good things? Here dm by 60, it is for the hours. For dn is the daily minutes good. The output will be between the correlation output will be between 0.57 and 0.58 for the number of good friends and daily minutes good. And the same thing, if you observe, good number of friends, daily hours good, the output also will be the same, between 0.57 and 0.58. This is about the correlation. Just now we have seen about the outlier. If you observe here in this figure 5.3, without outlier there is a much stronger correlation. If you observe, what is the index? Here we are taking 0 to 50 but not with the index 100. If you observe the diagram clearly when compared to our previous, please compare this one to the previous one. Here correlation with an outlier. Outlier is at index 100. If you see here in this diagram, outlier, without the outlier there is a much stronger correlation. If you observe here, correlation is very least, but here 0 to 50 the correlation is stronger without the outlier. Do you observe the two diagrams, without outlier and with outlier? Without the outlier, the correlation is much stronger. Is it clear? What is the correlation? What is the covariance of this one? Thank you for watching this video. Please subscribe this channel, Mary Madam Tech Classes. We will meet in another video. Until then, bye. Take care.